Hello and welcome back to another video. In this problem, we're asked to find the domain and range of the function g of x is equal to the square root of 16 minus x to the fourth. So the only restriction on the domain is that the square root has to be greater than or equal to 0. So 16 minus x to the fourth must be greater than or equal to 0. Adding x to the fourth to both sides. 16 therefore must have to be greater than or equal to x to the fourth. Taking the fourth root of both sides, we get 2 has to be greater than or equal to x. However, if x is negative, then the fourth root of x to the fourth is negative x. So we have to have negative 2 is x is greater than or equal to negative 2. So combining these two together, negative 2 is less than or equal to x, which is less than or equal to 2. This is the domain, which we can write as negative 2 to 2 inclusive. The range is all the values that this function hits within this interval. And we can see, if you plot certain points, that as this gets closer and closer to 0, this is obviously becoming 16 minus a smaller and smaller number. We get closer and closer to 0. The maximum value of this function becomes g of 0. Because x to the fourth for any value is going to be positive, we want the smallest x possible, whether it's positive or negative, to be subtracted from 16, because then we get 16 minus 0 to the fourth is 16 minus 0 is 16 is 4. Any other number would have a positive fourth power here that we'd be subtracting from 16, which would make it less than 16, which would make this less than 4. The largest value that's possible is, for example, g of 2, where we have 16 minus 2 to the fourth, which is 16 minus 16, which is the square root of 0, which is 0. If this number got any bigger, then we'd be subtracting something larger than 16. This would be negative. We'd be out of the domain. So 0 is the lowest we can go. So the range is from 0 to 4, also inclusive, so we do the brackets. So this domain of this function is negative 2 to 2 inclusive, and the range is 0 to 4 inclusive.